远不离不弃。你是我的小呀小苹果，怎么爱你都不嫌多。红红的小脸问我的心窝，点亮我生命的火。I wake up in the morning, I got Minecraft on my mind.
First, let's tackle the processes that take place from the mouth to the esophageal sphincter. Whilst chewing your food, a mechanical digestion process called mastication occurs. Mastication is the physical breakdown of macromolecules without changing their actual properties. Mastication occurs due to the hard palate sitting atop the oral cavity, as well as the grinding motion of the teeth. The salivary glands, namely the parotid gland, which is wrapped around the jawbone, facilitates the actual mastication process, releasing amylase enzymes in the form of saliva to turn starch into simple sugars. The nutrients you just ingested has now turned into bolus, a mixture of food and the amylase enzymes. Quick lesson on enzymes. Enzymes are basically huge proteins with active sites meant for certain molecules. Polymers, a chain of molecules that can be addressed as substrate, enters the active site of the enzyme and fits perfectly in their respective sites. The substrate breaks apart, forming new products. Then they leave the enzyme. Each molecule requires a different enzyme. For example, amylase breaks down starch, protease breaks down protein, and lipase breaks down fats. Back to the digestive system. The bolus travels down a hollow tube called the esophagus, which connects the oral cavity to the stomach. This is separated by the epiglottis, a flap with the purpose of preventing food from entering into the lungs, and the trachea, which allows the passage of air. A process called peristalsis occurs here, a muscle contraction allowing for solids and liquids to pass through the esophagus. Then, the bolus enters the esophageal sphincter.
After passing through the esophageal sphincter, the bolus enters the stomach. In the stomach, mechanical digestion occurs where the acid and enzymes break down the semisolid bolus into more liquid chyme. The stomach also produces pepsin, the enzyme that breaks down protein. The chyme then passes through the pyloric sphincter into a part of the small intestine called the duodenum. In the duodenum, the rest of the biomolecules are broken down by other enzymes from the liver and the pancreas. In the liver, a liquid called bile is produced and stored. The bile is made of lipase, an enzyme that breaks down lipids and other chemicals. It flows into the duodenum through the cystic duct and the common bile duct. Excess bile is stored in the gallbladder, a small organ underneath the liver. The pancreas is the main producer of enzymes that break down biomolecules. It produces trypsin to break down protein and amylase to break down carbohydrates. It also makes insulin and glucagon to regulate blood sugar levels. The enzymes flow through the pancreatic duct and combine with the common bile duct in the duodenum. The duodenum is where all the enzymes break down the polymers into smaller monomers, ready to be absorbed into the bloodstream in the next part of the small intestine, the jejunum.
The chyme enters the jejunum, which is located in the middle of the small intestine. The jejunum begins at the duodenojejunal flexure, which is the transition from the ascending part of the duodenum. The jejunum makes up around 2/5 of the entire small intestine, with the size varying anywhere from 1.5 to 3.5 meters. The main goal is to absorb nutrients, which includes sugars, fatty acids, and amino acids into the bloodstream. Absorption is able to occur because of the lining of villi along the jejunum surface. A process called peristalsis, which are the contractions of the muscles, helps move the nutrients down and happens very quickly in the jejunum. These absorbed nutrients are then able to enter the bloodstream, where they can then travel to the ileum. The ileum is the final stage of the small intestine and is also the longest part, as it's around 3.5 meters or 3/5 of the intestine. This important part of the system absorbs any of the other vitamins, bile salts, or other nutrients that wasn't able to be digested in the jejunum. The walls of the ileum are much thinner, which causes the peristaltic contractions to be much slower. Similar to the jejunum, its walls are covered in villi, and as stated is how absorption occurs. The ileum then leads to the ileocecal sphincter and into the large intestine. The villi, as mentioned, are vascular projections that are required in order to increase the surface area of a membrane. This is important because a greater surface area is used for absorption in the jejunum and ileum. Each contains a network of capillaries, and these provide an area for exchange of nutrients, oxygen, and etc.
Kivo the beast. Ah, finally, I've reached the Kekum station. I admit it's been a rough journey. Through the mouth, to the stomach, and through the winding paths of the small intestines. It hasn't been easy, but I may now begin my final trek through the large intestines. Wait, what's that music? Yo, poo man, it's me, Slav Intestines. And if you want to get through these colon, you need to pay up with some H2O and some electrolytes. Additionally, I can offer you a map of the area and tell you what each pot does, if that's in your interest. Luckily for you, I've brought plenty of water and electrolytes on my journey. Would you collect them now, or is there some other way of transaction? And as for the map, I would say that would be rather useful, wouldn't it, considering the long journey I have ahead? Okay then, in that case, I will give you a tour of the large intestines. Alright, right now, we're down here in the cacum. Down there, you got the appendix. We don't really know what it does, but just know that it's there. When you begin your journey, you'll start going up the ascending colon. When you're in this colon, my boss, the large intestines, will be start to suck all of your electrolytes and H2O out of you. That's how we get our payment. Now, after the ascending colon, you will go into the transverse colon, and you'll transcend reality as more H2O gets sucked out of you. After that, you go down the descending colon into the sigmoid colon, and finally you arrive at the rectum. Now note, the entire large intestines can be anywhere from around 1 meter to 2 meters long. Now, that's pretty long, so I wish you luck on your journey, traveler. Thank you, sir. I will be on my way now.
Yalla, let's go.
Uh-oh. Stinky poop.
Ah, all in a good day's work, I suppose, and... No, it can't be. Who's there? Ore no Mitsu to electrolyte wa motte nai da. But why are you doing this? Dakara, ore wa Dayuriya-sama desu. Dame da ne, dame yo, dame nano yo. Anta ga suki de, suki sugite, dore dake tsuyoi o sake de mo yugamanai omoide ga baka mitai.